So the next very important part is the, you can say, rules for IUPAC system of nomenclature. There are 5-6 rules, and let me explain some important rules. Like first cation, then anion. Always you put first cation, then anion. So first rule is the, during the nomenclature you write first cation, then anion. Second, after naming the cation, arrange the ligands alphabetically. If you are giving amino, bromido, chlorido, then you take pentamine, dibromido, trichlorido, because di, tri, penta are taken as the prefix, not in the alphabetic order, but amine A and aqua, water is given and amine is given, then amine AM taken first, then aqua, AQ, the way amine, bromido, chlorido, like this. So after naming the cation, arrange the ligands alphabetically, followed by central metal atom with oxygen number in Roman letter in parenthesis. Parenthesis, I mean a small bracket. Third, if complex is cationic or neutral, then usual name of central metal atom is written. Nothing is to be added as. For example, if you are getting the, you see, chromium, you write simply chromium. If you getting the nickel, you just write the name of the nickel and then you put the oxygen number like that. If you say silver, Ag, then you put simply silver and then you put the oxygen number. Then you can say zinc, like this, palladium, Palladium, palladium like this, cobalt, nickel, right? So in that case, when complex is, what is that? Cationic or neutral? But if complex is anionic, then the third rule, the very important rule, is the fourth rule. I mean, if complex is anionic, then ATE8 is added with central metal atom as suffix. For example, if you are getting zinc, so you write zincate. Zinc is not zinc, here it is zincate. Whatever the oxidation state, if it is the second, then you write the second. If it is third, you write the second, fourth, whatever it is. And if I say nickel, then you write nickelate. It is like this. Cobaltate, Ag, not silverate, argentate. Au, not gold, it is aurate. Copper, cuprate, C-U-P-E-R-A-T, cuprate. Iron, don't write irate, ferrate. Then you write palladium, palladate, P-A-L-L-A-D-A-T-E, like this, and then you put the parenthesis. So if complex is anionic, then in that way you have to write the name. It is to be added as a suffix in the central metal atom. Right. Next rule, if charge is visible on complex, then ion is added at the end of nomenclature if organic bidentate or polydentate ligands are present, then for 2, 3 and 4 we use not di, tri and tetra. No, we will not use the word. We use the Greek word. For 2 it is bis, for 3 it is tris, and for 4 it is tetra case. For 5 it is the penta case. Like that, the such alphabets are used. Right. And then for MB dentate ligands, the exposure of donor atom must be shown like this. If you are given thiocyanato SCN, then sulfur is used. Nitrito ONO, then O is used. Nitro, then N is used, like this. The word, the symbol which is going to donate the lone pair must be exposed like this. And then last is the last rule for the IUPAC system of nomenclature is complete the nomenclature in one statement. You try to accomplish the nomenclature in one statement without comma, dash and hyphen, except some few organic ligands like ethylene diamine. Then you can write ethane 1,2-diamine. There comma can be used. Otherwise you should not prefer comma, dash and hyphen and try to accomplish the name in one statement. Right. So the last rule is the try to complete the name in one statement without comma, dash or hyphen, like this. So these are the rules that we have to keep, you have to carry these rules in mind, retain in your mind, so that we can have the right system of nomenclature. So I give you few examples there. K4 FeCN whole 6. First cation, then anion. What the first rule is? The first cation, then anion. Potassium is the cation and this part is the anion. So first cation, then anion. And don't mention the 4 potassium to tetra potassium. If there are 2 potassium di, tri, no. Ionizable part prefix not mentioned. Simply you write potassium. Either in the left hand side or in the right hand side. If there are 2 SO4 here, then you don't write disulfate. No. Ionizable part prefix not used. Simply you write potassium. Potassium. After naming the cation, then arrange the ligands alphabetics. Here we have one kind of the ligand. So no question over the alphabetics. It is cyanido. How much cyanido? This is hexa cyanido. Then it is ferrate. Why it is ferrate? Why it is ferrate? Because of complex is the anionic complex. If complex will be cationic or neutral, then 8 is not added. But since it is the potassium is the positive charge, so whole complex is the negative charge. It is understood. So central metal atom, if it is iron, so you write ferrate. If cobalt, cobaltate. Palladium, palladate. Nickel, nickelate. Zinc, zincate. Like this. in right. You calculate the oxidation state, plus 1 into 4 plus x plus minus 1 into 6, sum is equal to 0, plus 4 plus x minus 6 equal to 0, so x is equal to plus 2. So you put in the Roman letters. Potassium hexacyanophilate. Now you can go for the other kind of the ligand, another kind of the complex compound, CO, NH3 5, bromine, SO4. It is the anion, sulfate is the anion, so whole part is the cation. So complex, completely cation. First cation, then anion. But cation is the full complex, so you arrange it alphabetic, the ligand. If it is cation, complex is cationic, then you follow the ligand as per the alphabetical amine. How many amine? Penta amine, bromido, it is cobalt, don't write cobaltate, and ionizable part has the normal system of nomenclature, sulfate, don't write sulfato, because sulfato, if sulfate will be inside the bracket, then it will act as a ligand, but here it is not used as a ligand. So it is the ionizable part of the counter ion, so its normal nomenclature is applied. So what the oxidation state? X plus 0 into 5 plus minus 1 plus minus 2 equal to 0. So x minus 3 equal to 0. So x is equal to plus 3. So you put it here, it is what? Like this. Third. Then Zn OH whole 4 and 2 positive. Tetra hydroxido, it is zinc or zincate. It is zinc because complex is anionic. X minus 4 is equal to plus 2 x, so it is here right minus zincate. So it is what actually, because of now it is zincate, and x minus 4 equal to minus 2, x equal to minus 2 plus 4, your answer is plus 2. Charge is visible, so you write here ion. So the way you can have the IUPAC system of nomenclature. So you solve all the questions from the text as well as exercise, and you follow the rules and apply all the rules, retain in your mind, and solve the question of the, you can see, IUPAC system of nomenclature. It's all right. Have a nice day to all of you. Thank you very much.